The welder's torch hissed and spat in the Oakland fog, casting dancing shadows across James Morrison's weathered face. His hands should have been steady. 23 years of shipbuilding experience demanded it, but they trembled as he watched the hull sections being lowered into place by crane. This wasn't how you built ships. This was madness. 4 days, he muttered, pulling his safety goggles up to his forehead. They're saying 4 goddamn days. Preparing and narrating this type of story took us long efforts and hard work. So, if you're enjoying the story, please consider subscribing to our channel. Beside him, Tommy Chen, barely 19 and fresh from a Sacramento farm, looked up from his welding practice. "What's wrong with 4 days? Mr. Kaiser says we can do it." James barked out a bitter laugh. "Kid, I've been building ships since before you were born. A Liberty ship is 441 feet long, weighs 14,000 tons, and has over 250,000 parts. The fastest yards on the East Coast take 7 months. Henry Kaiser's never built a ship in his life, and he's promising 4 days. He spat into the San Francisco Bay. It's suicide, for us and for every sailor who steps aboard one of these floating coffins. But even as James spoke those words, he felt the electric current of something unprecedented surging through Richmond Shipyard No. 3. Men and women, thousands of them, most who'd never seen an ocean before last month, moved with choreographed precision between prefabricated sections that shouldn't exist. Overhead cranes danced in patterns that violated every principle of sequential construction. And somewhere in a makeshift office overlooking this controlled chaos, Henry Kaiser was about to rewrite the rules of industrial production and change the course of World War II. The date was November 12, 1942. In exactly 96 hours, the SS Robert E. Peary would slide into the water as the fastest-built large ship in maritime history. But the story of how one gravel hauler from the Northwest convinced America to abandon 500 years of shipbuilding tradition began not in Richmond, but in the desperate, dark days after Pearl Harbor, when German U-boats were sending Allied ships to the bottom of the Atlantic faster than every shipyard in America could replace them combined. James Morrison didn't know it yet, but in 4 days he'd be weeping at the launching ceremony. And in 4 months, he'd be teaching Kaiser's impossible methods to British shipbuilders who'd been crafting vessels since the age of Drake. The torch in his hand reignited with a sharp pop, and James Morrison returned to welding a section of ship that, according to everything he knew, couldn't possibly float. He was about to learn that impossible was just another word for nobody's tried it yet. 6 months earlier, on a humid Washington, D.C. morning in May 1942, Henry Kaiser sat in a leather chair outside the office of Admiral Emory Land, chairman of the United States Maritime Commission. At 59, Kaiser cut an unusual figure in the capital's corridors of power. His round face and wire-rimmed glasses gave him the appearance of a friendly pharmacist, rather than the industrial titan who'd helped build the Hoover Dam, the Grand Coulee Dam, and the Oakland-San Francisco Bay Bridge. His assistant, Clay Bedford, paced nervously in the waiting area. "Henry, maybe we should reconsider. Shipbuilding isn't like concrete and steel construction. The traditional yards have been doing this for generations. We're going to look like fools." Kaiser's eyes twinkled behind his glasses, an expression Bedford had learned to recognize as either genius or lunacy, sometimes both. "Henry, do you know what the real problem is with experts? I'm sure you're about to tell me. They know too much about what can't be done." Kaiser leaned forward, his voice dropping to a conspiratorial whisper. "Every dam we built, they said it couldn't be done. Wrong location, wrong timeline, wrong materials. The Hoover Dam, experts said it would take 20 years. We finished it in 5. The Grand Coulee, they said we couldn't pour that much concrete continuously. We invented refrigeration pipes and did it anyway." Henry, with all respect, Concrete doesn't sink, ships do. Before Kaiser could respond, the office doors swung open. Admiral Land emerged, his face showing the strain of a man trying to win an ocean war with insufficient vessels. At 62, Land had spent 4 decades in the Navy and knew ships the way surgeons knew anatomy. The circles under his eyes told the story of sleepless nights spent calculating shipping losses against production capacity and finding the mathematics of defeat. "Mr. Kaiser, thank you for coming." Land's handshake was firm but weary. "I understand you have some ideas about shipbuilding." They settled into Land's office where a massive map of the Atlantic dominated one wall. Red pins marked sunken vessels. There were far too many of them, clustered in deadly groups along the convoy routes. Blue pins represented active Allied ships, and the ratio was becoming disturbingly unfavorable. "Gentlemen," Land began without preamble, "we are losing this war. Not on the battlefields of Europe or the Pacific, but right here." He gestured at the map. "In March, U-boats sank 95 ships. In April, 74. This month, we're on track to lose another 100. We're building ships as fast as we can. The entire American shipbuilding industry is working triple shifts, and we're still falling behind." Kaiser studied the map with the same intense focus he'd once applied to canyon topography. "How long does it take to build a Liberty ship?" "In the established East Coast yards, average of about 230 days from keel laying to launch. We've managed to get that down to about 150 days in some facilities." "And how many ships are we losing per day?" Land's jaw tightened. 3 to 4 on average. Kaiser did the mental arithmetic. "So, even if we could somehow launch a new ship every day from every yard in America, we'd still barely stay even with the losses. And that's assuming the U-boats don't get more efficient." "Which they are," Land confirmed grimly. "Admiral Donitz is refining Wolfpack tactics every week. British intelligence suggests he's planning to double the U-boat fleet by autumn. Mr. Kaiser, I appreciate your interest, but unless you can somehow conjure ships from thin air, I'm not sure what you think you can contribute. The maritime industry has been building ships the same way for centuries because it works." Kaiser stood up and walked to the map, tracing the convoy routes with one finger. "Admiral, may I tell you about a problem we had at the Hoover Dam?" Land exchanged a glance with his aide, clearly wondering if this was a waste of valuable time. "If you must." "In 1931, we needed to divert the Colorado River. The traditional method would have been to wait for low water season, build temporary cofferdams, and work around the flow. It would have taken 3 years before we could even start the real construction. We couldn't afford that time." "And?" "We drilled 4 tunnels through the canyon walls, each 50 feet in diameter. We diverted the entire Colorado River around the construction site. Experts said it was impossible. The scale was too large, the rock too unstable, the timeline too short. We did it in 1 year." Kaiser turned from the map, his eyes bright with the fervor of a man who'd made a career of achieving the impossible. "The point, Admiral, isn't that we did something unprecedented. It's that we stopped asking, 'How has it always been done?' and started asking, 'How does it need to be done?'" Land sat back in his chair, fingers steepled. "What exactly are you proposing?" "Give me a contract to build Liberty ships. Not 1 or 2, I'm talking about multiple shipyards, each capable of producing vessels at a rate that will make the traditional yards look like they're standing still." "Mr. Kaiser, you've never built a ship." "No, but I've built some of the largest structures on Earth, and I've done it by understanding something the experts often forget. It's not about the product, it's about the process." Kaiser pulled a folded newspaper from his jacket pocket. "I've been reading about these Liberty ships. The design was adapted from British tramp steamers, standardized for mass production, correct?" "Yes, the design is simple, reliable, and proven. But even with standardization,
Admiral, with respect, you're still thinking like a traditional shipbuilder. You're building ships the way medieval craftsmen built ships, one at a time, start to finish, with each vessel moving through sequential stages. What if we didn't? Land's expression shifted from polite dismissal to genuine curiosity. What do you mean?
Kaiser moved to Land's desk and grabbed a notepad. He sketched quickly, his hand moving with the practiced confidence of someone who'd spent decades translating vision into blueprint. At the dam, we didn't pour concrete for one section, wait for it to cure, then move to the next. We divided the structure into sections, worked on multiple areas simultaneously, and used new techniques, like cooling pipes embedded in the concrete, to speed up processes that traditionally took months. He drew a rough outline of a ship, then divided it into sections. What if we built a ship the way we build buildings? What if we prefabricated entire sections in different areas of the shipyard, then assembled them like pieces of a massive puzzle? What if we used welding instead of riveting? What if we trained workers in specialized tasks instead of expecting each person to be a master shipwright? Land studied the sketch. His lifetime of naval expertise warred with the desperate reality marked in red pins on his wall. The British have experimented with some prefabrication. It hasn't significantly reduced construction time. Because they're still constrained by traditional thinking. They prefabricate small components, then assemble them using traditional methods. I'm talking about prefabricating entire hull sections, deck houses, complete room modules with plumbing and electrical already installed. We bring them to the slip, weld them together, and launch. The structural integrity will be tested and proven before we launch a single ship, Admiral. I'm not proposing we build unsafe vessels. I'm proposing we build them faster by changing every assumption about how the process must work. Clay Bedford, who'd been silent throughout the exchange, finally spoke up. Henry, even if the Admiral agrees, where would we do this? Every shipyard on the West Coast is already at capacity. Kaiser's grin was that of a man who'd been waiting for exactly that question. We build new yards. I've already identified sites near Richmond, California. Deep water access, rail connections, plenty of space for prefabrication areas. We could have the first yard operational in 6 months. Land laughed, but it wasn't dismissive. It was the sound of a desperate man encountering an idea so audacious it might actually work. Mr. Kaiser, it takes years to build a functional shipyard. You're talking about what, multiple yards in 6 months, then immediately beginning production of ships faster than any yard in history? Yes. That's insane. Yes. Kaiser's smile never wavered. But Admiral, you just told me we're losing 3 to 4 ships per day. We need insane. Reasonable isn't working. The room fell silent except for the ticking of a grandfather clock in the corner. Land stood and walked to his window, looking out over the Potomac. His reflection in the glass showed a man weighing the risks of trusting an outsider against the certainty of defeat if nothing changed. How fast, Land finally asked, his back still to the room, how fast could you build a Liberty ship? Kaiser didn't hesitate. Give me the contract and the resources, and I'll have a ship in the water in less than a month from keel laying. Land turned sharply. A month? Mr. Kaiser, the fastest we've ever managed was 105 days, and that was considered miraculous. I'm not interested in miracles, Admiral. I'm interested in mathematics. If a ship has 250,000 parts, and you have 10,000 workers, and each worker is trained in specific repeatable tasks, and you have those parts pre-assembled into larger modules, and you use welding, which is 3 times faster than riveting, and you work 3 shifts around the clock. Kaiser paused. It's not a miracle, it's just arithmetic. Land returned to his desk and sat heavily. You understand that if you fail, you'll have wasted resources we can't afford to waste. Ships that fail at sea don't just cost money, they cost lives. I understand the stakes, Admiral. That's why I'm here. And if you give me this contract, you'll need workers, thousands of them. Where will you find experienced shipwrights? I won't. Kaiser's answer clearly surprised Land.
I'll train them. Farmers, mechanics, housewives, anyone who can follow instructions and isn't afraid of hard work. Shipbuilding has been a guild trade for too long. It doesn't need to be.
Farmers and housewives, Land repeated slowly. Building ships. Admiral, the British are putting women in factories to build Spitfires. The Russians have women flying combat aircraft. This isn't 1920, it's 1942, and we're in a total war. We need to use every resource available. Land opened a drawer and pulled out a thick folder. This is the Liberty ship specification. 441 feet long, 57 feet wide, 10,865 gross tons when loaded. 7 cargo holds, steam reciprocating engine, 2,500 horsepower, top speed of 11 knots. The design is standardized specifically to allow multiple yards to build to identical specifications. He slid the folder across the desk. If, and this is a very large if, I authorize this, you'll be building to these exact standards. No shortcuts, no improvisation on the design itself. Understood. I'm not proposing changing what we build, just how we build it. You'll need to prove the concept. Build one ship, successfully, using your methods. If it floats, if it passes inspection, if it performs as specified, we'll talk about expanding the contract. Kaiser extended his hand. You'll have your ship, Admiral, and I guarantee you won't be disappointed with the timeline. As they shook hands, Land said quietly, Mr. Kaiser, I'm authorizing this because we're desperate. But understand, every ship that goes to sea carries 100 men. If your methods compromise safety, if your ships break apart in Atlantic storms because you cut corners to chase speed, they won't, Kaiser said firmly. Speed without safety is just waste. I'm promising you both. As Kaiser and Bedford left the Maritime Commission building, stepping into the humid D.C. afternoon, Bedford exhaled slowly. Henry, you just promised to revolutionize an industry you know nothing about, build shipyards that don't exist, train workers who've never held a welding torch, and produce ships faster than anyone in history. And you committed to doing it in under a month. Kaiser flagged down a taxi, his mind already racing through logistics, worker recruitment, material supply chains, and 1,000 other details. Clay, you know what the beautiful thing about never having done something before is? What? You don't know what's impossible. Kaiser climbed into the taxi, and as it pulled away from the curb, he added, Now let's go prove the experts wrong again. Richmond, California, in the spring of 1942, was a sleepy town of 23,000 people, known primarily for oil refineries and its view across the bay to San Francisco. The waterfront was a mix of fishing docks, warehouses, and marshland that flooded during high tide. It was, by any reasonable assessment, an unlikely location for one of the most ambitious industrial projects in American history. Henry Kaiser stood on a mudflat near Point Richmond, his suit shoes sinking into the marshy ground, and surveyed what would become Richmond Shipyard No. 2. Bedford stood beside him, along with a young engineer named Roger Stevens, who'd worked on the Grand Coulee Dam and had been tasked with turning Kaiser's vision into concrete reality. "This is it?" Stevens asked, looking at the soggy ground with unconcealed doubt. "Henry, this isn't even solid land. We can't build a shipyard on a marsh." Kaiser was unmoved. "So we fill it. Roger, how long to create a solid foundation across this entire area?" Stevens pulled out a surveyor's notebook, studying the topographical maps they'd commissioned. "Conventional approach, 8 to 12 months minimum. We'd need to drive pilings deep into the bedrock, which is 30 to 40 feet down in most areas. Then we'd need to fill and compact, install drainage, create the basic infrastructure. How long if we do it unconventionally?" Stevens looked up from his notes. "I'm sorry." "The Hoover Dam foundation. What did the experts say about building on that canyon floor?" A slow smile spread across Stevens' face. He'd been with Kaiser long enough to know where this was going. "They said it couldn't be done in less than 2 years. We did it in 14 months. And we did it by bringing in every dragline, dump truck, and piece of heavy equipment we could rent, borrow, or steal. We worked 3 shifts. We didn't wait for one section to be perfect before starting the next."
Kaiser turned to Stevens, his eyes intense behind his glasses. "I need this yard operational in 6 months. Not perfect, operational. We'll improve it as we go. How do we do it?"
Stevens closed his notebook. "We'll need about 300,000 cubic yards of fill. If we can access the dredging operations in the bay, we might be able to accelerate that. We bring in multiple crews working simultaneously on different sections. Instead of driving traditional pilings, we could use shorter friction pilings with a broader base. Not ideal for a permanent structure, but for a wartime shipyard that needs to be operational fast, it could work. Make it happen." "What about the cranes?" "That's actually the easier part. The heavy lift gantry cranes we need are being manufactured on the East Coast. 6-week delivery once we order them. We'll need massive concrete foundations for those, but we can start pouring those as soon as we have solid ground." Bedford had been taking notes, but now he looked up with concern. "Henry, we're talking about multiple massive cranes. The cost alone." "Clay, run the numbers for me. A traditional yard with traditional methods builds 1 Liberty ship every 230 days. That means in a year, they can produce, what, maybe 1.5 ships per slip? How many slips are we planning?" "The initial design calls for 4 slips in Yard 2, Stevens answered. "So, with traditional methods, that's 6 ships per year. Now, if we can cut the build time to 30 days, and I'm being conservative, we could potentially produce 12 ships per slip per year, 48 ships from 1 yard annually. The cost of the cranes, the infrastructure, the unconventional methods, all of it pays for itself in productivity." Kaiser picked up a stick and drew in the mud. "It's not about minimizing cost, it's about maximizing output." Over the next hour, they walked the site, with Stevens pointing out where different facilities would go. "The prefabrication area here near the rail lines will have sections for hull construction, deck assemblies, deck houses. Each prefab area specializes in specific modules. The modules move to the assembly areas, then to the slips for final integration." "How many workers?" "For full operation, at least 10,000 in this yard alone. Maybe more if we're running at peak capacity." Kaiser nodded slowly. "We'll need housing. These people won't all be locals. We'll need childcare facilities. Many of the workers will be women with families. Medical facilities, cafeterias, transportation. We're not just building a shipyard. We're building a community." "Henry," Bedford interjected, "the cost of all that infrastructure is an investment in productivity. Clay, a worker who has to worry about where their kids are or how they'll get to work or whether they can afford lunch is not a productive worker. We take care of our people, they'll take care of us." A truck pulled up, and a woman in her mid-40s climbed out, carrying a briefcase and looking thoroughly out of place in the mudflat. Dr. Catherine Walsh was a civil engineer, rare enough for her gender in 1942 and even rarer for her specialization in rapid construction techniques. Kaiser had recruited her from a university position specifically for this project. "Dr. Walsh," Kaiser greeted her warmly, "what do you think of our site?" Walsh surveyed the marsh with a professional eye. "It's terrible. Unstable ground, prone to flooding, insufficient drainage. You'll face constant issues with settlement and structural stability." She paused, and a slight smile crossed her face. "Which means it's perfect for proving your theories. If we can build here, we can build anywhere." "That's the spirit." Rogers outlined the basic timeline. "I want you to challenge every assumption. Where can we accelerate? What can we do simultaneously instead of sequentially?" Walsh pulled out her own notes. "I've been studying the Liberty ship specifications. The hull is divided into major sections: bow, stern, midship. Traditionally, these are built sequentially in the slip. What if we built them simultaneously in the prefab area, transported them to the slip, and welded them together?" Stevens frowned. "The weight would be immense. We'd need transporters capable of moving sections weighing hundreds of tons. So we build them," Kaiser said simply. "What else?" "The deck house," Walsh continued, warming to the topic. "It's treated as a separate structure that gets integrated in the late process. What if we built complete deck house modules? Walls, floors, ceilings, plumbing, electrical, everything. Then lifted the entire thing to the hull as a single unit." "Structural integrity?" asked Stevens. "We'd need to ensure the connection points are reinforced, but it's feasible. It would save weeks of in-place construction time."
Walsh flipped through her notes. The engine room is another opportunity. Instead of installing equipment piece by piece, we could create engine room modules with the main engine, auxiliary machinery, piping, and electrical already integrated. Lower the entire assembly into the hull cavity. Kaiser listened intently, occasionally nodding. This was the kind of thinking he had been hoping for, not accepting the traditional limitations, but questioning why they existed in the first place. The real constraint, Walsh said, is going to be the workforce. These prefabrication and modular assembly techniques require precision. Sections need to align perfectly when we bring them together. That requires skilled workers, and skilled workers take years to train.
What if we don't need them to be traditionally skilled? Kaiser countered. What if we broke down each task into its simplest components? Instead of one master shipwright who knows everything, we train people in specific, repeatable tasks. This person only welds this type of joint. This person only installs this type of electrical connection. This person only... Henry Ford's assembly line, Bedford interrupted. You're applying automobile manufacturing principles to shipbuilding. Why not? A Liberty ship is just a very large machine. Each component can be standardized. Each task can be specialized. Kaiser turned to Walsh. What do you think? Walsh considered carefully. It would work for many operations, but ships aren't cars. They face structural stresses that require more than just following a procedure. You'd still need experienced foremen and inspectors overseeing each stage. Agreed. We hired the best shipwrights we can find for supervisory roles. They oversee teams of specialized workers. The supervisors handle the complex decision-making, while the team members execute specific, well-defined tasks. Stevens was sketching in his notebook again. We'd need extensive training facilities, welding simulators, mock-up sections for practice, detailed work instructions for every position. Build them, Kaiser said. Before we lay a single keel, I want a fully operational training center. Workers spend 2 weeks learning their specific role until they can do it in their sleep. Then they go to the line. As the afternoon wore on, the group moved from discussion to concrete planning. Walsh calculated structural load requirements, Stevens mapped out the construction sequence for the yard itself, Bedford started a running list of equipment needs, material orders, and recruitment requirements. We'll need steel, Stevens said, enormous quantities. The supply chain is already stretched thin amid war production. Kaiser pulled out a small notebook where he kept contacts and began flipping through pages. I know people at Bethlehem Steel. We helped them with some foundation work on their Pennsylvania plant, and we have relationships with steel mills in California. We'll need to coordinate closely with the Maritime Commission to ensure we're in the allocation queue. Welding equipment, Walsh added. If we're going to replace riveting with welding as the primary joining method, we'll need hundreds of welding stations, thousands of electrodes, proper ventilation systems. Put together a complete list. I want to place orders by the end of the week. Bedford looked up from his notes. Henry, do you have any idea how much this is going to cost? No, Kaiser admitted cheerfully, but I know how much it costs to lose this war. Put together a budget. Make it realistic. Include contingencies, then add 20% because we're doing things that have never been done before. The Maritime Commission needs ships more than they need cost savings. As the sun began to set over the San Francisco Bay, casting long shadows across the mudflat, the small group stood in silence for a moment. In 6 months, this marsh would be transformed into an industrial complex capable of producing the largest ships in America. It seemed impossible. All right, Kaiser said finally. Roger, you're in charge of site development. Catherine, you're heading up process engineering and worker training. Clay, you're coordinating with the Maritime Commission, managing the budget and handling equipment procurement. I'll focus on recruiting workers and establishing the management structure. When do we start? Stevens asked. Kaiser checked his watch. It's 4:30. I'd say we started 4 hours ago. First equipment arrives Monday morning. I want drag lines moving dirt by Monday afternoon. Walsh shook her head in amazement. You're serious? Dr. Walsh, there are sailors dying in the Atlantic because we don't have enough ships. Every day we delay is another day closer to losing this war. I'm absolutely serious.
As they drove back towards San Francisco that evening, Bedford voiced the concern that had been growing in his mind. "Henry, what if we fail? What if we build this whole facility and then can't deliver on the speed you promised?" Kaiser was quiet for a long moment, watching the lights of San Francisco come into view across the bay. "Clay, do you remember what we told the workers at the Hoover Dam when they asked if it could really be done? You told them it had to be done, so we'd figure out how. And we did. This is no different. We have to do this, so we will. The alternative is unacceptable." Kaiser turned to Bedford. "But you're right to think about failure. So, we won't fail. We'll work harder, think smarter, and move faster than anyone thinks possible. And if we hit obstacles, which we will, we'll go around them, over them, or straight through them. But we won't stop." The car crossed the Bay Bridge, and Kaiser looked back at the dark mudflat they had just left. In his mind, he could already see it. Cranes rising against the sky, workers moving with purposeful efficiency, steel sections being welded together, and most importantly, ships sliding into the water at a pace that would astonish the world. "One more thing," Kaiser added. "We're going to document everything, every innovation, every problem, every solution. When this works, and it will work, I want to be able to teach these methods to every shipyard in America. This isn't just about Richmond shipyards. It's about changing the entire industry." Bedford made another note. "You want to create a training program for other yards?" "Eventually, but first we prove it works. Actions speak louder than words. When we start launching ships every few weeks, everyone will want to know how we did it. That's when we share the knowledge." They drove in silence for a while, each lost in their own thoughts about the enormous undertaking ahead. Finally, Bedford asked, "Do you ever worry that we're in over our heads?" Kaiser smiled. "Every single day. That's how I know we're doing something worth doing." Margaret Chen had never welded anything in her life. At 32, she'd spent the last decade as a schoolteacher in Sacramento, educating children in arithmetic, reading, and geography. But in June 1942, with her husband deployed to the Pacific and 2 children to support, teaching salary wasn't enough. She'd seen the advertisements in the Sacramento Bee: "Wanted, workers for defense industry, no experience necessary, training provided, $1.20 per hour." Now she stood in a classroom at the Richmond Training Center, a hastily constructed building that still smelled of fresh paint and sawdust, along with 50 other women and men, watching an instructor demonstrate the basics of arc welding. "The electrode creates an electrical arc between itself and the metal," explained Robert Jameson, a grizzled shipwright who'd been lured out of retirement to train Kaiser's new workforce. "The arc melts both the electrode and the base metal, fusing them together. Sounds simple, right?" A nervous laugh rippled through the class. "It's not," Jameson continued bluntly. "A bad weld can kill someone. A ship hull with weak welds will crack in a storm and send 100 sailors to the bottom of the Atlantic. So, we're going to practice until you can do this perfectly, every single time. Even when you're tired, even when it's 3 in the morning, even when you've already done 100 welds that day." Margaret felt her stomach tighten. She'd expected this to be difficult, but the stark reminder of the stakes made her hands tremble slightly. "But here's the good news," Jameson said, his gruff voice softening. "Every one of you can learn this. It's not magic, it's not some mysterious craft that takes a lifetime to master. It's a skill, and skills can be taught. Mr. Kaiser believes that, and after 40 years in shipyards, I'm starting to believe it too." Over the next 2 weeks, Margaret learned welding. Not just the theory, but hours upon hours of practice. She learned to maintain the correct arc length, to move at a consistent speed, to identify good welds from bad ones. Her arms ached from holding the welding torch. Her eyes strained despite the protective goggles. She went home each night exhausted, smelling of metal and smoke. But she also discovered something unexpected. She was good at it. "Mrs. Chen," Jameson called out on the 8th day of training, "come here." Margaret's heart sank. She'd been working on a practice piece, and she was certain she'd made an error. Jameson examined her weld closely, running his finger along the bead. "Class, come look at this." As the other trainees gathered around, Margaret felt her face flush. "This is a textbook weld, consistent penetration, no porosity, excellent bead profile. Mrs. Chen, how long did you say you'd been welding?" 8 days, sir." 8 days, Jameson repeated, his voice carrying a note of wonder. "I've seen shipwrights with 8 years of experience produce worse." He looked at Margaret directly. "When you finish this training program, I'm recommending you for the critical weld team. That's the group that handles structural joints, the welds that absolutely cannot fail." Margaret felt a surge of pride mixed with terror. "Sir, I'm not sure I'm ready for it." "None of us are ready for what we're being asked to do," Jameson interrupted. "But Mr. Kaiser says we don't have the luxury of waiting until we're ready. We learn by doing. And you, Mrs. Chen, have a gift for this. Don't waste it." Across the training facility, in another workshop, James Morrison was having a very different experience. After 23 years building ships the traditional way, every instinct in his body rebelled against what he was being taught. The instructor, a young engineer named David Park, who looked barely old enough to shave, was explaining the prefabrication process. "Each hull section is built in the prefab area as a complete module," Park explained, pointing to a detailed diagram. "All the interior bulkheads, piping runs, electrical conduits, everything is installed before the section leaves the prefab facility. Then we transport it to the slip and weld it to the adjacent sections." James raised his hand. "That's backward. You can't properly fit interior components until the hull is complete and you can take actual measurements." Park didn't seem offended by the challenge. "In traditional construction, yes, but we're not doing traditional construction. Each module is built to precise specifications based on engineering drawings. The drawings are so detailed and accurate that if the sections are built correctly, they'll align perfectly during final assembly." "And if they don't align?" "Then we have a problem," Park admitted, "which is why quality control is critical at every stage. We're not building faster by cutting corners. We're building faster by being more precise and organized than traditional methods require." James shook his head. "Son, I've been building ships since before you were born. I've seen modern methods fail over and over because they ignore the realities of working with metal and water. Ships flex, they settle, they shift. You can't just weld together prefab sections like you're building a model." Park met James's skepticism with patience. "Mr. Morrison, I've read your file. You worked on the USS Lexington, the SS President Coolidge, and a dozen other vessels. You're exactly the kind of experienced shipwright we need, but I'm asking you to consider that maybe, just maybe, there's a better way. There's tradition for a reason, and there's innovation for a reason too. The Germans are sinking our ships faster than we can replace them. Tradition isn't working, so Mr. Kaiser is trying something different." Park pulled out a thick binder. "These are the engineering specifications for Liberty ship construction using prefabrication methods. They were developed by some of the best naval architects in the country. I'm not asking you to abandon your experience. I'm asking you to apply it to a new approach." James took the binder reluctantly, flipping through pages of detailed specifications and assembly procedures. Despite his skepticism, he had to admit the engineering was thorough, perhaps more thorough than traditional methods that relied heavily on master craftsmen making judgment calls.
Over the following weeks, something unexpected happened. James Morrison and Margaret Chen found themselves working on the same hull section in Prefab Area 7. The grizzled veteran and the former schoolteacher formed an unlikely partnership. "The angle on this bulkhead support isn't right," James said one morning, examining Margaret's work with a critical eye. Margaret bristled. She'd followed the specifications exactly. "The drawing shows—" "I know what the drawing shows," James interrupted.
but his tone was instructional rather than dismissive. "But see how this join connects to the deck plate? In a storm, that's going to be a stress point. The weld needs to be reinforced here and here." He marked the spots with chalk. Margaret studied the points he'd indicated, then looked back at the specifications. "That's not in the procedure." "No, it's not, because the procedure was written by engineers who understand theory. I'm talking about reality. What happens when a ship is in 30-foot seas and every joint is being tested?" He paused, then added with grudging respect, "But your weld quality is excellent, better than most men I've worked with. You follow the procedure perfectly. What I'm teaching you is when to go beyond the procedure." This became the pattern and the secret to Kaiser's success. Experienced shipwrights like James brought decades of practical knowledge about what actually worked at sea. New workers like Margaret brought precision, trainability, and a willingness to follow standardized procedures without the baggage of "that's not how we've always done it." Together, they created something neither could have achieved alone. By November 1942, Richmond Shipyard No. 3 was a 24-hour symphony of industrial might. 3 shifts of workers, 18,000 strong, moved through the facility like a precision clockwork. The mudflat that had seemed so impossible just 6 months earlier now bristled with gantry cranes, prefabrication buildings, and 7 shipways where steel vessels took shape at unprecedented speed. On November 8th, Admiral Emory Land arrived for an inspection, accompanied by newspaper reporters and military officials. He'd authorized Kaiser's experiment with deep reservations. And while the Richmond yards had already launched several Liberty ships successfully, he wanted to see the operation firsthand. What he witnessed left him speechless. In Prefab Area 1, complete hull sections, each weighing over 200 tons, were being constructed on assembly fixtures. Workers swarmed over the structures like ants on a purposeful mission. Welders worked in coordinated teams, each person responsible for specific joint types. Inspectors moved behind them with templates and measuring devices, checking tolerances to the 16th of an inch. "How long to build one of these sections?" Land asked Roger Stevens, who was conducting the tour. "This particular bow section? About 4 days from first steel to complete module, ready for transport to the slip." Land did quick mental arithmetic. A traditional yard would spend 4 days just preparing the materials. That's, I don't even know what to call that. "Efficient," Stevens suggested with a slight smile. At shipway number 7, the keel of the SS Robert E. Peary had been laid 4 days earlier. Now, massive cranes were lowering the bow section into place. The operation required perfect coordination. The bow section, complete with interior bulkheads and structural reinforcements, weighed 180 tons and had to align with the keel to tolerances measured in fractions of an inch. Margaret Chen was part of the critical weld team securing the bow section to the keel. Despite her mere 6 months of experience, Robert Jameson had been right. She had a gift. Her hands were steady as she ran bead after bead of weld along the massive join. Beside her, James Morrison worked on the opposite side of that joint. He'd stopped fighting the new methods around August and had become one of Kaiser's most effective foremen. He still brought his old-school knowledge to bear, but now he used it to enhance the new procedures rather than resist them. "Temp is rising on this plate," James called out. "Margaret, skip ahead 20 feet and work back. We'll let this section cool." It was the kind of practical adjustment that made the system work, following the procedure while adapting to real-world conditions. By November 10th, the midship sections were in place. By November 11th, the stern section was lowered and welded. The deckhouse module completely outfitted with bridge equipment, radar, communications, and crew quarters, was lifted on as a single 75-ton unit and secured in just 6 hours. Henry Kaiser walked the shipway on the evening of November 11th, accompanied by Clay Bedford and Dr. Catherine Walsh. The ship was nearly complete, an impossible sight given that the keel had been laid just 4 days earlier.
"The engine room module goes in tomorrow morning," Walsh reported, consulting her clipboard. "Propeller and rudder are already installed. Electrical connections between modules are 95% complete. Plumbing pressure tests passed. We're actually ahead of schedule." "Ahead of a 4-day schedule," Bedford said, shaking his head in wonder. "Henry, even I thought you were crazy. I worked the numbers 100 times and they should work, but seeing it actually happen—" Kaiser's eyes gleamed behind his glasses. "Clay, you know what the beautiful thing is? This is just the beginning. Every ship we build, we get faster. We're learning new efficiencies every day. I wouldn't be surprised if we eventually get this down to 3 days, maybe even 2. Admiral Land, who had been observing the evening shift changeover, approached the group. His skepticism had evaporated over the 2 days he'd spent watching Kaiser's operation. "Mr. Kaiser, I owe you an apology. When you came to my office in May, I thought you were a dreamer at best, a charlatan at worst. I was wrong." "You were appropriately skeptical, Admiral. If someone had told me 6 months ago that we'd be launching ships this fast, I'm not sure I would have believed it either." "How many ships can you produce with this method?" Kaiser pulled out a small notebook where he tracked production metrics. "Yard 3 has 7 shipways. At current efficiency, we can launch a ship every 4 to 5 days from each way once we're at full rhythm. That's roughly 50 ships per year from just this one yard. And Admiral, we're building 2 more yards." Land's expression shifted from amazement to something approaching hope, the first genuine hope he'd felt since the war began. "If you can maintain that pace, Mr. Kaiser, you're not just helping us win the war, you might be the reason we win the war." November 12, 1942 dawned cold and foggy over San Francisco Bay. By 9 a.m., thousands of workers had gathered at Shipway 7, along with dozens of reporters, military officials, and dignitaries. The SS Robert E. Peary sat on the ways, fully outfitted and ready for launch, just 4 days, 15 hours, and 29 minutes after her keel had been laid. It was a world record that would stand for decades. Margaret Chen stood with her welding crew, still hardly believing she'd helped build this massive vessel. The ship towered above her, 441 feet of steel that, according to everything the old-timers had told her, shouldn't exist. Yet there it was, solid and real, ready to carry troops and supplies across the Atlantic. James Morrison stood nearby, and Margaret noticed his eyes were wet. The tough old shipwright who'd insisted it couldn't be done was crying as he looked at what they'd accomplished together. "James," Margaret asked quietly, "are you okay?" He wiped his eyes roughly. "I spent 43 years building ships, convinced I knew the only way it could be done. Then this crazy dam builder shows up and proves me wrong in 6 months." He turned to Margaret. "You know what the worst part is? He was right. This is better. We're building better ships, faster, and training people like you who never would have had the chance under the old system." Henry Kaiser stood at the podium, preparing to give the christening speech. But before he began, he did something unexpected. He called Margaret Chen and James Morrison to join him. "Ladies and gentlemen," Kaiser announced to the crowd, "these 2 people represent what we've accomplished here. Margaret Chen was a schoolteacher 6 months ago. She'd never held a welding torch in her life. James Morrison has been building ships since 1919. He thought everything we were doing was impossible. Together, they've created something extraordinary." He turned to face them directly. "Margaret, you proved that dedication and training can overcome any lack of experience. James, you proved that wisdom and experience can enhance innovation rather than resist it. This ship exists because thousands of workers like you were willing to do something that had never been done before." The crowd erupted in applause.
Margaret felt tears streaming down her face. James clasped her shoulder in a gesture of respect that transcended their different backgrounds. Kaiser continued his speech, his voice carrying across the shipyard. 4 days ago, this ship was just drawings and steel. Today, she'll carry the name of Robert E. Peary, the explorer who proved that the impossible was merely the improbable. She'll sail to England carrying supplies that will help win this war. And she won't be alone. Behind her, 6 more ships are already under construction in our 7 shipways. Next month, we'll launch 15 ships. The month after that, 20. He paused, looking out over the sea of workers, farmers and teachers, mechanics and housewives, young and old, every race and background represented. Admiral Donitz and his U-boats may be efficient, but we're going to be more efficient. For every ship they sink, we're going to launch 2. For every ton of supplies they send to the bottom, we're going to deliver 3. We're going to bury them in an avalanche of American industrial might, and we're going to do it because people like you proved that impossible is just another word for nobody's tried it yet.
The christening bottle shattered against the bow. The SS Robert E. Peary slid down the ways and into San Francisco Bay, her launch watched by thousands who had made her possible. As she hit the water and floated perfectly sound, perfectly seaworthy, a roar went up from the crowd that could be heard across the bay. The SS Robert E. Peary made 27 crossings of the Atlantic, surviving storms and U-boat attacks, delivering over 150,000 tons of critical supplies. She was never damaged by enemy action and served faithfully until being scrapped in 1963. But her real legacy wasn't her service record. It was what she proved possible. Kaiser's Richmond shipyards went on to build 747 ships during World War II. Other shipyards across America adopted his prefabrication and assembly line methods. By 1943, American shipyards were launching 3 ships per day, an output that overwhelmed German U-boat capacity and turned the tide of the Battle of the Atlantic. The methods Kaiser pioneered, modular construction, specialized training, welding over riveting, prefabrication at scale, became standard practice in shipbuilding and influenced manufacturing across dozens of industries. His willingness to question every assumption about how things had to be done opened the door to innovations that continue to this day. Margaret Chen continued working as a welder until 1945, when she became a welding inspector and trainer. After the war, she used her savings to open a welding school in Sacramento, training a new generation in the craft she'd mastered. She lived to be 92 and kept in her living room a photograph of herself standing beside the SS Robert E. Peary on launch day. James Morrison became a consultant to the Maritime Commission, traveling to shipyards across America and Britain to teach Kaiser's methods. He never lost his respect for traditional shipbuilding, but he combined that wisdom with the new techniques, creating training programs that produced the most skilled shipbuilders of the post-war era. Henry Kaiser moved on to other ventures, automobiles, steel, healthcare, but he never forgot the lessons of the shipyards. When asked late in life about his greatest achievement, he didn't mention the Hoover Dam or the Golden Gate Bridge. He talked about the workers of Richmond, the people who'd never built ships but who changed the world by being willing to try. On the wall of the now closed Richmond Shipyard No. 3, a plaque commemorates what happened there. It reads simply, "Here the impossible became routine." But perhaps the real memorial is something less tangible. The understanding that expertise and tradition, while valuable, should never prevent us from questioning whether there might be a better way. That sometimes the greatest innovations come not from those who know a field intimately, but from those willing to ask, why not, when everyone else is saying we can't. The SS Robert E. Peary was just a ship. Steel and rivets and welding beads, no different in function from the thousands of other Liberty ships that sailed during the war. But she was also a monument to human ingenuity, to challenging assumptions, and to what ordinary people can achieve when they're given the tools,
training, and trust to do extraordinary things. 4 days. 4 days to build a ship that experts said would take 7 months. 4 days that proved impossible was just another word for nobody's tried it yet. And somewhere, in workshops and factories and laboratories around the world, people are still proving it. Thank you so much for joining me on this incredible journey through one of World War II's most remarkable untold stories. If this tale of innovation, determination, and the triumph of human ingenuity moved you, please show your support by hitting that like button and sharing this video with friends who love history, engineering, or stories about ordinary people doing extraordinary things. Don't forget to subscribe to the channel and ring that notification bell so you never miss our next deep dive into the fascinating stories that changed our world. We've got more incredible narratives coming your way. Stories of invention, courage, and the moments when someone dared to ask, "What if?" and changed everything.